Well, another instrument we're going to learn in this lab is going to be called the height gauge. Now, for the height gauge, is simply as the calibers, but it's going to be sitting on the table instead of carried by hand. The height here is going to be measured on the ruler as we do with the caliber. So we just put the part in, okay, and touch that and take the reading from the ruler directly. So once again, it's going to be full millimeters and the 10th of the millimeter value. The calibration process is going to be done by using the gauge blocks. We can put the gauge block on the table and do the measurement. We always be sure that we put on a flat surface with the reading as the end is going to be attached to the table, is going to be reading 0 value. Now, usually nobody using that anymore. For more advanced process, we can either use this one, which is semi-automatic one on the side, again to come back to it later, or using the electronic one. The electronic one is have a microcomputer, which can give you the measurement directly. This can do the measurement for multiple functions, as you can see here, checking the height from the top, the height from the bottom, the diameter of the circle, the gap between two heights, for example, the gap here, and the thickness. And also it can check what will be the natural line for the part, and also it can do the checking for the curvature of the surface. It give you the average value. So first again, to turn on the machine, it's have a button here in the back like the PC. Turn on. It's going to start up like a normal computer, uploading the software, the operating system. Okay, it's give you the reading. So now it's still uploading thing. Now the first thing we are going to do is doing the calibration process. Now once again, there's no calibration about the accuracy. It's only going to be the calibration to set the value of the 0. So it's asked you first to take the cantilever to the top. You always carry it from here. You take it to the top. Now you hear the beep. Now the thing is on the top. Now the next thing is I need to take it to the bottom. So to do that, first I'm going to bring that to here. You can see it's have the air cushion, and then I'm going to take this one down until it's going to touch the table. We're talking about this prop. This prop should touch the table. Now the reading we're having here is, say, is 0.05. I need to calibrate the device to set the origin. To do that, we have multiple options here. One of the bottom here says 0. So we set the 0 value. I'm going to press that, and I need to choose if I'm going to use the absolute, the incremental, or absolute and incremental. And well, once again, to talk about the incremental and the absolute. Absolute means that all the reading is going to be referenced to the origin. The incremental is the next reading is going to be referenced to the present reading, and so on. So it's a 1 for the absolute. I'm going to find the key 1, which is here. Press 1, and this one will go to the bottom. Okay, then done. I said that the bottom or the table surface is the 0 level. So if I'm going to take this one up, you can see that this value is changing. But because I'm not doing any actual reading now, so this value doesn't change. My first test is going to be checking the height of that surface. I'm going to put it somewhere where the probe is going to touch it when it's going to come down. So I think that this will be a good position. It's reading as 144.83. But I would like to check the height from the top, so the best thing to do is press this button. So if I'm going to take this one a little bit up, you will see the thing will happen is that press this one. It's telling you that this device is going down, the probe is going down, touch the surface. When you hit the beep, it's going to give you the reading here. So it's 144.8227. Now you can see that the reading is giving you the reading in the 10,000ths of millimeter. That's very good accuracy. Again, I supposed to check multiple points on that surface and get the average and get the standard deviation and get the percentage of the error, and that's something we are going to do later in the subject which called the advanced manufacturing, or any whatever the name of the subject is going to be later. We're doing that in that subject. So again, take another reading. Okay, and I got 144.8275, so it's changes slightly. Now, the reason of changing slightly, because we had machining. In the machining process, it's actually very hard to get the flat surface required. Other finishing operation may be going to give you the accuracy you would like to have. Now, the other operation that this device can do is checking the height from the bottom. So I can check the height of this surface from the reference, which is the bottom table. So I can put the device in this position, and when it's going to go up, it's going to touch the surface. Now, because this part is aluminium, so I need to support it by hand when I'm going to press the bottom. So I'm going to push it once again a little bit down, so I'm going to have the chance to see how it's going to work. Press that, tell you that the thing is going up. Touch the table, give us a reading is 115.4529. Now that's the height of this surface from the table. Now let's see what the other options we have. Let's check that, where it's going to be the height between two gaps. Okay, now this will be the height between these two surfaces. Now, this operation is going to be quite tricky because I need to hold the pot and put the probe in the middle. When I'm going to press the bottom, it's going to go either go up first, touch the surface, then go down, touch the surface automatically, or vice versa. So that means it's either going to go down or up. I don't remember the sequence. To do that, we have a gap. So this is a gap. Two lines, and we need to check what will be the gap between them. Click this option, so it's going down, touch it, and it's going up automatically. You can see I didn't touch anything in the device. And it's going to give you the reading. So the height of the upper surface was 100. I think this for the lower surface, 100, and the gap between the two surfaces is 30.0151 millimeters. So the gap we have here is equal to 30.015 millimeters. When you can see this shape, we're always going to avoid measuring as close as possible to the corners, because you can see these corners are rounded. They are not sharp, not 90 degree. We're usually getting that because the tool we have for the milling operation have a rounded shape. So it's always going to cut a fillet instead of cutting the corners. Now, the other option we can have is check what will be the thickness of the part. So I'm going to put the device here in the middle, and I'm going to check the thickness of the part we have. Now, to check the thickness, we need to have this photo, which is a solid part. Press on that, so it's going to go up. Sorry, I'm going to check the upper one. Sorry, stop that, cancel, and I'm going to cancel the process because I put it on the side instead of the bottom. Okay, now once again, I'm going to check the thickness of that. Now once again, because I'm wearing glasses with the camera, so that's why it's showing me a single eye, and that's why I cannot see the things probably. Again, I'm going to press that. It's going to go up. Touch the surface. Now it's asked me to take the things to the top and press the bottom of the enter. So again, to take the probe to the top, I'll put it in this position so we can see it when it's come down. Take it away from the edge, and I'm going to press enter. So the measuring will resume, touching the top surface, and now it's telling me that the lower side value was 72, and the width, the average height is 72, and the width was 25.0005 millimeters. Now, the other operation we can do with this device is checking the diameter. Now, the checking of the diameter is going to be quite tricky because we need to have the movement of the probe to be checking the arc, moving, attaching to the arc at the bottom, then moving, attaching the arc at the top. To do that, actually, we need to move the part by ourselves because the device is not going to be moved forward and backward, and the part is not going to be moved, but we can move it ourselves. Now, I'm usually using this image to show the student the movement we need to do for the device, for the probe. So what actually we're going to do is we put the probe in such position like that. Then I'm going to press measure. The probe will go down to here. I'm holding the part firmly, and I'm going to hear the peep. When I'm going to hear the peep, I'm going to pull the part toward myself. The probe is going to be moving in this arc. When it's going to reach the same height, it's going to hear another peep. So you stop moving the part. The probe will go by itself to the top here. When attaching this surface and feel some resistance, it's going to hear another peep. So you will start to push the part to the opposite direction, and the probe will move in this arc until it's going to reach the same level. You will hear another peep, and it's going to give you the average value for the diameters has been measured. So to show you that, putting the probe at the point I told you about. So if I'm going to take a look from the side, the probe is sitting in this position. When I explained to you there, it actually was looking from this direction. Now, I'm going to press that, but I need to hold the part firmly first. Press that. Now the probe is coming down. Hear the peep. I start to pull the part toward myself slowly. Stop. Let it go up. Now start to push it the other way. Stop. Now, it's telling me that the diameter is 40.0372 millimeters. 40.0372 millimeters. Now, I'm going to take the same part to the machine there, which is called the CMM machine, or the coordination measurement machine, and I will try to check the same diameter. So just remember this value is 40.3072. Now I will take the measurement for the other circle here using the same technique. So I'm going to put the probe here and press measure. So it's going to go down, beep, pull it, push it, and this diameter is 25.0284 millimeters. So that's what we have for the height gauge from Motoyoto. That's the name of the manufacturer, and the model we have here is LS600E. We're usually using this one for, once again, for the advanced manufacturing to do hundreds of measurements, and then the student needs to do the calculation to find what would be the error percentage we have for this device. We'll still have an error anyway. Now, that's all for the height gauge, and our next step is going to be the surface roughness, and then we are going to go for the CMM. Thank you very much, and we are going to see you soon.